Hey guys, I made here a little worksheet type deal for you guys who are still struggling with Sig Figs. I know Sig Figs is something really important that we all really need to learn, and it's really good that you guys joined boot camp because I can tell you that you will use Sig Figs not only in the fall, but you will use it in the spring as well. Like, you'll continuously use this throughout, I think, all your chemistry courses. So it's really important that you know what the rules are when it comes to sig figs and how to apply them, and really understand them, because it can get confusing sometimes, really, when you have like long dimensional analysis problems and you have to do adding and subtracting and you're multiplying, and it just gets really confusing. And especially in word problems, it's really important for you to know what your sig figs are, because they can count for a lot. One thing that I like to do in the fall whenever I was taking Gen Chem was making little cheat sheets for every like subject that we were talking about that week. I don't know, I'm a very visual learner, so I like to have everything that we were learning on one piece of paper, just completely there. I did this with formulas because there's lots of formulas that you guys are going to need to memorize. Um, and yeah, in the spring we weren't able to use any notes, but using and making these cheat sheets while studying really did help me. So yeah, um, there's basically 4 rules to figuring out sig figs. Then the first rule is all non-zero numbers are always significant. So that's like the number one thing, is if it's not a zero, it's pretty much significant. So I have 2 examples here. So 15 has 2 sig figs because the 1 and the 5 are significant. And 145 has 3 sig figs because the 1, 4, and 5 are all significant. But that goes on to the second rule. So if you have a 0 in between those numbers, it is significant. And usually zeros aren't significant, but if it's within if it's between 2 non-zeros, it's always going to be significant. So this is pretty much a long number, but you have 5 sig figs in that. So 1, 2, 3, 4, 5. Yeah. The professors really go into detail on sig figs in the videos, so if you want to watch their videos, it's a lot helpful. This is just kind of like an overview of it. So all zeros to the left of a non-zero are not significant. That's a really important thing to know. I used to always trip myself up whenever I was doing word problems, and if you don't have the right sig figs at the end of the problem, you can get counted off points. It's usually not that many, but it is points. So for this example, all these zeros right here are to the left of the 5, so they are not significant. So the 5 is the only significant digit that we have. On this one, we have kind of 2 rules here going on. So we have all these 3 zeros are not significant, but this 0 right here is significant. So these 3 numbers will be significant digits. And then there's one more rule. So at decimal places, if there's a decimal, any number to the right of the decimal is going to be significant. So even if it's a 0. So for this number, we have 2 because we have the decimal right here, and then this is to the right. So that's going to be significant. Same with this. So all of this is going to be significant. And then this kind of goes on with 2 rules here. So basically all this is significant because we have a non-zero number, and then we have a decimal, and then everything to the right of that is going to be significant. So yeah, subtracting and adding is something that I really struggled with because I would always forget that you have to round to the lowest decimal place. So we have 2 sig figs right here, and then we have 1 sig fig right there. We have to use the 1 sig fig. However, you still have to add them together to get the total number, and then you decide where the sig figs are. So this is 3.5, so this is obviously going to round to 4, and 4 is going to be our only digit that we use because we have 1 sig fig. And now the next one, we have 5.31 minus 2.2. This has 3 sig figs and this has 2 sig figs. So this is the lowest number of sig figs that we have. So our final answer will have 2 sig figs in it. So we subtract, we get 3.11, and then we have to round to 2 sig figs. So kind of think of it like you're chopping off that last number. And if this were, like, let's say this was a 6, this would round it up. So our final answer would be 3.2, but we would still have 2 sig figs in our final answer. Multiplying is really easy if you understand these top rules and finding out how many sig figs all your numbers are. So let's say you have a word problem. You're going to actually want to, like, this is something I did. I don't know if anybody else did it, but if I had a word problem with several different numbers in it, I would actually like write down, so like let's say there was a number that was like 0.5, and then let's say it's mLs, and let's say we had 2.2 grams. Actually, let's make that 2.3 gram, 2.23. And let's see. Actually, I'm going to do this. So let's say this was 78.8 grams per mole. So yeah, this is 1 sig fig. This is going to have 3 sig figs. And this, on the other hand, I don't know what this is on the periodic table, but let's say this was an actual measurement and this was giving you a conversion. So like this would usually be on Chem 101, it would be like in parentheses or something. I personally would not use this number as a sig fig determinant because it's kind of like a quantitative like number. Like you have, that's like a set number. Like it's not changing. So we have 1 sig fig and 3 sig figs. So we're always going to round to the lowest number of sig figs. So our final answer would have to be something with 1 sig fig in it. Yeah. So I don't know. I don't think that I made a really good example here, but if that helped, I'm hoping it helped. But yeah, moving on to the next thing is multiplying and dividing. Really easy. You basically just look at which one has the lowest number of sig figs. So this has 3 sig figs, this has 1 sig fig. Your final answer will have 1 sig fig. This has 3 sig figs, that has 2 sig figs. Your final answer will have 2 sig figs. It's kind of simple, but it is something that will trip you up for sure. I definitely make mistakes all the time, and I'm sure I've lost points on quizzes and exams by just not paying attention and just messing up the sig figs. And that's something that, yes, you don't lose a lot of points on, but it is worth, I mean, if 1 point can mean a lot at the end of it. So yeah, I have a couple practice problems here for you guys that you could do if you want to pause the video and answer them. And then check when we go through it and check if you got the right answer. Be great. If not, we're about to go through it all. So this number right here, the number of sig figs is going to be 5 sig figs because we have all non-zero numbers. So we have 1, 2, 3, 4, 5 sig figs. And this is going to be rule 1 from our rules above here. So all non-zero numbers are going to be significant. Okay, and now for our second one. So again, we have 1, 2, 3, 4 sig figs because they're not zeros. And like we said with rule 1, all non-zero numbers are significant. So this one, we have 3 zeros here. But because of rule 2, they're in between 2 non-zero numbers. So because of that rule, we have 1, 2, 3, 4, 5 sig figs. So our final answer, if that was like the lowest number of sig figs we had, that our final answer would have 5 sig figs as well. And rule 1 goes into play in that as well. So here we have 1, 2, 3, 4 zeros here, but they are all non-significant. They are not significant because they are to the left of the non-zero number. So this is 1 sig fig. And this goes on to rule 1 and 3. So 3 was all zeros to the left are not significant. So now on this one we have 3 zeros as well. Or we have 3 zeros, but they are to the right of a non-zero number. So here we have 1, 2, 3, 4, 5 sig figs. And this goes off of rule 1, 2, and 4 actually. 1 and 4, which was 4, all zeros to the right are always significant of a decimal. Yeah. So next one, we have 0 there, we have a 0 there, and we have a 0 there. So this 0 is going to be, the first 0 is going to be significant because it's between two non-zero numbers. This 0 is going to be significant because it's between two non-zero numbers. And even this 0 is going to be significant because it's to the right of a decimal. So we have 1, 2, 3, 4, 5, 6 sig figs. And this actually goes into play with rule 1, 2, and 4. So now this number. Okay, we have 6 zeros here. But notice how there isn't a decimal place. If there was a decimal place right here, and we had this, then they would be significant. But there is no decimal place. So all these zeros right here are not significant. So we have 1 sig fig. So that 3 is the only sig fig that we have. So our final answer would have 1 sig fig in it. And this goes on rule 1. So like I said, so there is a 0 here and a decimal. So these 3 digits right here are going to be significant. However, if we just had 10, we would just have 1 sig fig. So this has 3 sig figs. And this is off of rule 1 and rule 4. Okay, and now we have, so we have zeros to the left. So these zeros right here are not going to be significant. So you have 1, 2, 3, 4 sig figs. And this goes off of rule 1, 2, 3, and 4. So yeah, there's tons of practice online. Chem 101 has some really good practice problems for you guys to look at. These were more simpler problems. I would definitely recommend going through Chem 101 if you have the textbook already, going through the textbook and trying to figure out sig figs through there. That'd be great. Even if you don't want to answer the problems, just like looking at a question and determining what sig figs is going to be in the final answer. That's a great way to practice. I know there's tons of practice online that you can look up. Other than that, if you guys have any questions about this, feel free to email me. Thank you.